Now, next speaker, do we have a thumbs up for Tilly Hamilton? Oh, it's over there. Welcome. Right, terrific. On person. Tilly Hamilton, Medical University of Edinburgh. Sex and age-specific performance of the ASSIGN risk score. Very close to my heart because I'm one of the authors. For the prediction of cardiovascular events in the general population. Please, Tilly, go ahead. You've got 10 minutes in total. Will you find your question?
Okay. Hi everyone, my name's Tilly and I'm a final year medical student at Edinburgh University, and today I would like to present my research on the sex and age specific performance of the ASSIGN risk score for the prediction of cardiovascular events in the general population. So as we heard earlier, the ASSIGN risk score is used to predict an individual's 10-year probability of developing cardiovascular disease based on their baseline characteristics and risk factors. This score is then used by clinicians to guide decisions around preventative strategies for these individuals. ASSIGN's use is currently recommended in the Scottish population by the ASSIGN guidelines. Now, currently we know that there are sex inequalities in cardiovascular healthcare. However, despite this, little is actually known about the sex-specific performance of ASSIGN or about its performance in other subgroups, such as age groups. So my research aimed to evaluate the sex and age-specific performance of the ASSIGN risk score in the general population. And then it aimed to recalibrate ASSIGN in order to negate any of the discrepancies that we saw. So we did this by using the Generation Scotland Scottish Family Health Study, which was a longitudinal cohort study with almost 20,000 participants. To start with, we excluded any of the participants who had a baseline cardiovascular disease, were under 35 years old, or had missing data, which left us with 12,936 participants. We defined our primary outcomes as death from cardiovascular causes, any hospital diagnosis of cardiovascular or cerebrovascular disease, and any coronary artery intervention. We then divided our population into subgroups based on their sex and then on their age, with age groups defined as those under 60 years and 6 years and older. We then produced calibration plots in order to analyse the performance of ASSIGN, and then reproduce these calibration plots following recalibration. So looking at our population, 61% were female, and of these women, they were more likely to have family history and rheumatoid arthritis, whereas the men were more likely to have diabetes, were more likely to smoke, have high blood pressure, and be taking lipid-modifying and antihypertensive medication. The other risk factors such as age, cholesterol levels, and deprivation score were equal. So what do we find? On the screen here are the calibration plots that we produced to analyse the sex-specific performance of ASSIGN. Calibration plots are useful tools in analysing performance of risk scores, as they are able to directly compare the probability that's predicted by the risk score, which is shown on the x-axis, to the actual observed probability seen in a population, which is shown on a y-axis. The more closely that these data points correlate, the better the risk score is performing, i.e. the closer the data points are falling to the line of best fit, the better the risk score is performing. And as you can see, that for both men and women, data points are falling below the line of best fit, which means that ASSIGN is over-predicting risk for both men and women. We can also see that for women, the data points are falling further away from the line of best fit, meaning that ASSIGN is performing worse in women than it is in men. Next, we divided our population based on their age as well as their sex. I'd like to draw your attention just to the data for the women currently, as the trends are more clearly seen here. And as you can see that for the women that are 6 years and over, ASSIGN is performing worse than for the women that are under 6 years. You can see that for the 6 years and over, across all of the risk deciles, ASSIGN is over-predicting risk, whereas for the under 6 years women, over-prediction is only occurring for the women at higher risk. A similar trend is also seen for the men, but to a lesser extent. And finally, we tried to recalibrate the assigned risk score to negate any of the discrepancies that were previously seen. So the two graphs on the left are repeats of the graphs that you just saw on the previous slide that shows assigned performance before recalibration. And the two graphs on the right are showing assigned performance following recalibration. And as you can see, that for both the under 60 years, the top row, and the 60 years and over, the bottom row, assigned performance is improved following recalibration, as all of the data points are now falling closer to the line of best fit than they were previously. A similar trend is also seen for the men, but the effect is not as noteworthy, as assign wasn't performing as badly in men as it was in women to start with. So what can we conclude? Firstly, that the assigned risk score overestimates future cardiovascular events, with the worst performance being in women, particularly in elderly women. And finally, which is the final conclusion, carries on from the talk that we heard earlier, that recalibration can successfully improve the performance of assign for both men and women across both age groups, and may indeed be a powerful tool in improving the performance of other cardiovascular risk scores. Thank you very much. These are my acknowledgements.
Tilly, thank you very much. That was terrific. And we do have a couple of minutes for questions. Tilly, so what magic recalibration have you done to change a sign? You didn't actually really elaborate on how this actually works. Just tell us a bit more about that.
So in order to recalibrate, we did it in two stages. Within the assigned score to start with, there is the baseline survival. And that was based on the original population that the assigned score was created for. And then, so we calculated the baseline survival for the Generation Scotland Scottish Family Health Study, and then replaced the baseline survival with the original one that was in the original equation. And then the second stage was for each of the risk scores that were included in the assigned score, they have a beta coefficient in front of them. And we calculated a correction factor to correct the beta coefficient to make the risk scores more applicable to the mean that is in the mean of our current day population, rather than the mean of the previous population.
Tilly, thank you. Other questions? Tilly, one of the things when you have a risk score, and I was an author of a sign, that you always underestimate risk in young women when you use a 10-year risk score. Now, say you're a woman who's 49, is premenopausal, with a cholesterol of 9 or 8, and HDL of 1, she will not reach a 10-year risk of myocardial infarction that would warrant treatment, yet her lifetime risk is very high. Now, you tell us, now, because you've spent a bit of time in this, about your perception of 10-year risks stratification schemes versus lifetime risk. What do you want to tell us about that?
I think obviously if you could create a risk score that had a lifetime risk.
Well, we do have them with GBS score.
That would probably not have the same problems that a sign faces. Yeah, sorry. I'm not sure.
Any other questions? One question over here. No. Tilly desperate for tea. Fair enough. We'll stop now. Tilly, thank you very much. That was great. Thank you.